Hi everyone. Today we're going to do exercise 2.1 of class 9 NCERT. The chapter is Polynomials. This is the first exercise of this chapter and let's get right to it. So the first question says, which of the following expressions are polynomials in one variable and which are not? State reasons for your answer. The first part of the question is 4x square minus 3x plus 7. Now we need to check two things here. Firstly, if it is a polynomial, and secondly, if it is in one variable. Now if we remember the definition of a polynomial, it is any expression where the power of the variables are whole numbers. Here we can see that there are three terms in this polynomial. This is the first one, this is the second one, this is the third one. All of them have variables where the first variable has a power of 2, the second one has a power of 1, and the third one, well, we could write 7 as 7 into x to the power 0. Recall that x to the power 0 is equal to 1. So here we have all the expressions of x and their powers being whole numbers, which proves that this is a polynomial. Further, there is only a single variable of x in this question, and hence this makes it a polynomial of one variable. The second part of the question is y square plus root 2. Here again we can see the powers of the variable are whole numbers. Y square has a power of 2, root 2 has a power of 0, and hence we know that this is a polynomial. Further, again, we have only y and no other variable present in this expression, which makes this also a polynomial with one variable. Now the third part of this question is 3 under root t plus t under root 2. Now this expression is also an expression in one variable, the variable being t. However, it is not a polynomial. How do we know that? We can represent this expression in the following form as well. Now here, the variable t has a power of 1 by 2, which is not a whole number, and hence by the definition of a polynomial it does not satisfy, which makes this not a polynomial. Moving to the fourth part. The fourth part is y plus 2 upon y. Here again, this expression is in a one variable, but it is not a polynomial. If we represent this expression in a different way, it can be written as y plus 2y to the power minus 1. Here again, the power of y is not a whole number, which makes this expression not a polynomial. Now the fifth part of the question is x to the power 10 plus y cube plus t to the power 50. Here we can see that the powers of all the variables are whole numbers, 10, 3 and 50 being whole numbers. However, although this is a polynomial, it is not a polynomial in one variable. We can clearly see three different variables, x, y and t in this expression, and hence this is not a polynomial in one variable. It is a polynomial in three variables. And that brings us to the end of question number 1. Question number 2 of the exercise says, write the coefficient of x square in each of the following. The first part is 2 plus x square plus x. Here we'll observe the term with x square. Out here we can clearly see that the coefficient of x square is 1. The second part of the question is to minus x square plus x cube. Here again we'll observe the coefficient of x square, which is this term over here. In this case, the coefficient is minus 1. Third part of this question is pi by 2 x square plus x. Here, this first term of this polynomial is the term with x square, and we can see that the coefficient of x square is pi by 2. Moving to the fourth part. The fourth part is under root 2x minus 1. Now visually, we can see that this polynomial does not have a term with x square. However, we can definitely write this as 0 into x square plus root 2x minus 1. I have rewritten this expression in this form with an x square term added to it. This implies that the coefficient of x square in this expression is 0. That brings us to the end of question number 2. Moving to question number 3. Question number 3 is asking us to give one example each of a binomial of degree 35 and a monomial of degree 100. Now, if we recall, a binomial is nothing but a polynomial with two terms. A degree of a polynomial is the highest power of the variable in the polynomial. So which means we want a polynomial with two terms, and the highest degree of, or the highest power of the variable in this binomial should be 35. And one such example could be 5 into x to the power 35 plus 4x square. Here, this is a binomial since it has two terms, and the highest power of the variable is 35, making this a binomial of degree 35. Similarly, a monomial of degree 100 will be a polynomial with a single term. That's what a monomial means. And the highest power of the variable will be 100. So 7y to the power 100 is a monomial since it has a single term, and the power of this term is 100, making the degree of this polynomial 100. And that's the solution to question number 3. Question number 4 of this exercise is asking us to write the degree of each of the following polynomials. As we recall, the degree of a polynomial is the highest power of the variable in the expression. The first part is 5x cubed plus 4x square plus 7x. Here we can see the variable x has the highest power as 3 in the first term over here, which makes the degree as 3. Moving on to the second part. The second part is 4 minus y square. Here the variable is y, and the highest power of y is in the second term out here, and the power being 2, which makes the degree of this polynomial 2. The third part of this question is 5t minus under root 7. Here the variable in this polynomial is t, and the highest power that t has is 1, which is in the first term itself. So the degree of this polynomial is 1. The fourth part is simply the number 3. Here the variable is not visible. However, we could rewrite this as 3 into x to the power 0. We know that x to the power 0 is equal to 1, so this would mean the same thing. And by rewriting it like this, we can visually see that the degree of this polynomial is 0. The fifth question of this exercise is asking us to classify the following as linear, quadratic, and cubic polynomials. Now, just as a refresher, linear polynomials are those with degree 1, quadratic polynomials have degree 2, and cubic polynomials have degree 3. So we'll need to find the degree of the following polynomials and classify them as linear, quadratic, or cubic. The first part is x square plus x. Here the highest power is 2, which makes this a quadratic polynomial. Second part is x minus x cube. Here the highest power is 3, which makes this a cubic polynomial. Third part of the question is y plus y square plus 4. Here the highest degree or the highest power of the variable is 2, which makes this a quadratic polynomial. The fourth part is 1 plus x. The highest power of the variable x over here is 1, which makes this a linear polynomial. The fifth part is 3t. The variable t over here has the highest power of 1, which makes this also a linear polynomial. The sixth part is r square. Now the variable r over here has the power 2, and it's the only term in this polynomial. So degree 2 polynomials are called quadratic polynomials. The seventh part is 7x cube. Here the highest power of the variable x is 3, making this a cubic polynomial. And that brings us to the end of this exercise. Thank you for watching this video. I'll be back with further exercises of the NCERT. In case of any questions or comments, leave a comment below or reach out to me on the email ID mentioned in the description. Thanks again for watching.